Hello everyone, welcome back to CATIA training series. Today we are continue the pattern tool and go one step deeper into real industrial design. Let's learn how professionals create complex repeated structures in seconds.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming steel into art.
Hello everyone. Today I want to continue the rectangular pattern lesson. So far you learned how to duplicate a model in one linear direction. Now we want to duplicate a model in two directions. I also have a slanted line on the screen. First I activate the tool. I keep the same previous settings. In the object box, I click and then select pad 1 in the specification tree. In the reference element box, I click to make it blue. I right click and select the x-axis. Now I open the second part of the settings window. I click the V symbol in the parameters and choose a spacing and length mode. I set a spacing to 70 mm and length to 280 mm. The software calculates 5 instances automatically in this direction. Now I select the slanted line as the second reference element. The software shows a wireframe preview. I click OK. The model is duplicated. Here you must pay attention to 2 points. First, we did not choose the replication mode in the second direction like in the first direction. Second, the selected direction was not perpendicular to the x-axis. I hide part body and activate body 2. I activate the pattern tool again. In parameters, I click the V symbol. I select the last mode. With this option, I can duplicate a model with different spacing values. Now in the spacing field, I have only one value. This value is applied to all distances by default. I set the direction to the y-axis. I click Preview. I rotate the model in space. I see that instead of one spacing value, several values are shown. I double-click one of these values. A window opens and shows the value field. I set the value to 100. I click OK. You can see the spacing changed to 100 millimeters. I click OK on the definition window of Pattern tool. You can see the duplicated models. I activate the Pattern tool again. In both first direction and second direction, I set instance and spacing mode 6 instances and 70 millimeters spacing. I create the pattern in X and Y directions. I click Preview. Note the distance between edges of the model to main planes. You can see the model is duplicated in 2 directions. The pattern center and axis are on the first model, the created block. Pay attention to the numbers on the direction arrows. Now I click More to see additional options. This section has 3 parts. The first part is called Position Object in Pattern. There are 3 options here. The first 2 options define the position of the original model in the pattern. For example, if I enter 3 in row in direction 1, after clicking Preview, the original model is placed in the first row in direction 1. Now we are in top view. The original model has not moved. Instead, 2 rows are removed from the end and 2 rows are created before it. The third option is rotation angle. If I change the angle here, the pattern rotates by that value. The rotation keeps the angle between the 2 directions fixed. I set the angle to 45 degrees. I click Preview. You can see the pattern rotated. The vertical and horizontal edges of the blocks did not change relative to the axis. Only the directions were rotated. Even if I change currently to Path 3 and activate Keep Specification. The angle of the block edges does not change. But one important thing is seen. In the replicated models, the fillets and the center hole of the original model were removed. The reason is that we changed from current solid to Path 3 in the Object option. Note that Path 3 was just the initial cube. In the More section, there is Simplified representation. If the pattern has many instances, it uses a lot of memory. This slows down the system. This option helps reduce memory usage. When it is active, some models are not displayed. I changed the number from 6 to 20. Without this option, I click Preview. The computer takes time to display all models. I activate this option and create the pattern again. The system responds faster. Only a few models are displayed. All models still exist, they are just hidden. The third part is a staggered pattern definition. This creates a special pattern type. With the option in this section, the rows of the pattern are shifted one by one. Suppose the previous pattern, top view, is active. Now I enable a staggered option. Rows are shifted by 35 mm alternately. This displacement number is equal to half distance between the cubes. This value is calculated automatically by the software. I click Preview. You can see the pattern. A box will appear next to the Stagger Step option. The number 35 mm is currently written inside it. This box is active. I double click inside the box so that it turns blue. I change the number to 50. I click on Preview. You can see that amount of movement of the pattern rows is equal to 50 mm. Below this option there are two square buttons. By clicking on each, you can see that the shifted rows change. There is another option next to the staggered option. This is called self-half of spacing. When this option is enabled, the displacement value will be fixed and cannot be changed. Here we cannot control the offset manually. Now I explain Keep Specification. This option also exists in the Mirror tool. It works the same here. Imagine this shape. A cylinder with up to next extrusion on both sides. Now I pattern it in two directions. I activate the tool. I set the parameters. I click on Preview. The models are not connected to the top surface. I click OK. Now I'll double click on the pattern created in the design tree to open its settings window. I activate Keep Specification. I click Preview. Now the cylinders are connected to the top surface. In the first case, only dimensions were copied, but with this option, all features like up to next are preserved. Now let's talk more about this tool. If the pattern object is not a simple feature, for example it has fillets and holes, we must make sure all features are selected together. You have a solution. Before activating the tool, first press Shift key on your keyboard, then with your mouse select first and last items in order. Now all elements are selected. Activate the pattern tool. You can see all of them are listed in the object option. In this case, all elements are patterned as one complete solid. This helps to keep the full geometry, including holes and fillets, in all pattern instances. Another important case is when we pattern a pocket solid or a pad with fillet. Here, the pocket or fillet of the pad are dependent on the original solid. If the patterned object is created outside the original solid boundary, CATIA may show an error. This happens because the reference geometry is not valid in the view position. To avoid this problem, we must pattern the model in a way that does not lose its dependency on the original model. This is the end of the linear pattern lesson. Patterns are very important tools in design. They increase working speed. Mastering them is very important. In exercises, you will learn more about them. I hope you enjoyed this lesson. Follow the lesson carefully. Goodbye until next lesson.
Let's build the future. Come with me.